Awesome. Cool. So let's just get started. So hi, everyone. Today we're going to talk about how you can learn how to be an ML hero using automated machine learning. So before we begin, I do want to introduce myself. So yes, I'm Aniththa Umamahesan. I'm a program manager on the Microsoft Azure Machine Learning team. I'm specifically focused on automated ML. I graduated from the University of Waterloo and have a background in computing and financial management. And yes, as mentioned earlier, my latest mission is to accelerate and democratize AI via automated machine learning. So let's go ahead and take a look at what's on the agenda for today. So to start off, we're going to go over into an intro to machine learning, talk about why automated machine learning. We'll dive right into the capabilities after. And then I do have a couple demos prepared for you guys today. So we'll go through the demos in terms of personas. And then finally, we could talk about how you can get started with your own scenarios. And if we do have time, we'll go to the Q&A process. So let's begin. So as we all know, AI is everywhere. It can be simple as predicting how much money you have in a bank or who to send a loan offer to. If you have a restaurant, it can be like how much food to keep on hand to have customers satisfied and to reduce waste. So as more industries rely on big data to make choices, data science has become increasingly important across all industries. Just like cloud computing was fundamental in the explosion of startups, machine learning will likely power the next generation of applications crafted by developers, but also directly used by consumers and business tools. So let's go ahead and take a look at the machine learning process. As a data scientist or developer, I want to simplify and streamline the model creation process because building models can be tedious and iterative. We start by cleaning our data, then choosing an algorithm, then tuning our hyperparameters, and we continue to iterate on this process until we find that optimized model. As you can see, this process is definitely time-consuming. So just let's dive into an example of this, like how much is this car worth? And in order to do this, what we'll have to do in the process is first choose features, and then choose an algorithm, tune our parameters. So since we're figuring out the price of a car, let's just say we go with mileage, car brand, and year of make. Maybe go with gradient boosted as an algorithm, and maybe even tune our parameters like this. And this returns a model of 30%. And let's just say we're optimizing on the metric accuracy. So looking at that, 30% accuracy is definitely not good enough. So what I would do is I'll continue to iterate until I find that optimized model of maybe say 95%. Definitely much better than that original 30%. But again, you see, this process is time consuming. So the current process needs practitioners who are skilled in ML, such as data scientists. What if we can simplify this process? What if we can enable those who are novice in the area to create machine learning models? What if we can enable those same skilled professionals to be more efficient and productive? And that's exactly where Azure's automated machine learning comes in. With automated ML, what you do is pick an algorithm and hyperparameters for you, and it'll generate a model that's ready for deployment. The model then can be downloaded to be further customized as well. And let me just show you what I really mean by this. With AutoML, what we expect you to do as a user is bring your data, and then what you'll need to do is set up some configurations and constraints. What I mean by this, you'll need to identify what is your task type. Is it classification, regression, or time series forecasting? And you might want to specify some constraints, such as saying you want like some early stopping criteria. Maybe you just want to run your experiment for 3 hours, or maybe you want to make your experiment end once it reaches a specific metric threshold. So those are the kind of things you'll do here. And then what AutoML does is it'll intelligently test multiple models for you and return the optimized model, like that. So now that we know what automated ML is, let's go ahead and look at our mission. So our current mission is to enable automated building of machine learning with the goal of democratizing, accelerating, and scaling AI. And what I mean by this is, let's just say you have a data science team with varying levels of experience. With AutoML, you are able to expedite this entire data science process. And so this is where the whole democratized AI piece comes in. Now, if you have a smaller team of data scientists, with AutoML, you are able to make the most out of these limited resources. So what I mean here is that you're going to be able to improve the productivity of data scientists. And finally, we have seen scenarios where customers want to build multiple machine learning models in parallel. And now they can do that in an automated way. And that's what we mean by scale AI. So that's why our mission is to enable automated building of machine learning with the goal of accelerating, democratizing, and scaling AI. So now that we know how automated ML works, let's go ahead and look at the capabilities. So we'll start off. I'll tell you a little background about how automated ML came through. So it's based off of Microsoft research. So the brain was trained with several millions of experiments, and it uses what is called collaborative filtering and Bayesian optimization. I kind of like to think about this tool as something similar to Netflix. If you used Netflix before, you'll notice after watching a couple movies, it starts recommending the next movie that you want to watch. And usually that is actually the movie you want to watch. And that's exactly how these models are being recommended. AutoML currently supports classification, regression, and time series forecasting task types. And what's great about this is it's privacy preserving. And what we mean by this is that we don't look at your data. We only look at the metadata. So the number of features, the type of features you have, that kind of information to make the predictions. So now we'll dive into a little bit step by step into the machine learning flow. So we'll start off with the data requirements. So right now, AutoML expects a single flat data set, or we call it tabular data. And if your data is not labeled, for example, if column names are not identified, we will go ahead and name them as column 1, 2, and 3, and so on. You do have a couple options into how you can bring your data into AutoML. You could either do a local upload, blob, data lake, Azure SQL database, and you see a bunch of listed on the slide here. I'll show you a little more from our demos later on in the presentation, but this is just to give you an idea how you could bring in your data. Now, our value proposition is to support machine learning scenarios without compromise. And if you are working with large data, we are able to support that. Additionally, if you are working on scenarios where you are, for example, if you're creating a predictive model to forecast sales on a retail store, you might notice that weather data and holiday data can impact your results. Now, with Azure Machine Learning, you're able to get access to Azure Open Data Sets, so you can bring in those data sets to improve the quality of your models. Other specific examples that we currently support are public holidays, historical weather, and US population. The next thing I want to cover is data guardrails. So right now, AutoML supports class imbalance, train test split, missing value imputation, detect high cardinality features, we detect leaky features, overfitting, and model interpretability. We currently do the detection and some alerting, just so that you know what's going on with your data. When I do dive into the demos, I'll show you where the guardrail steps takes place, so you get a better understanding of how it works. The next thing I want to cover is featureization. So we currently do deep learning with BERT and BiLSTM for NLP. We also currently support some automatic featureization and feature engineering. We have heard that customers often want to customize their feature engineering, and the whole value prop here is to enable data scientists with knowledge on how the data contributes to the model, resulting in better accuracy. So right now, AutoML allows you to customize your feature engineering as well. So you could do stuff like blocking transformers, overriding column purpose, choosing to include or exclude columns in training, and deciding how to impute missing values. So these are the kinds of things you could do with the featureization step. So now we're going to dive into the training portion. And as I mentioned earlier, AutoML currently does support classification, regression, and time series forecasting. We have a bunch of classical statistical models, but we've also added some additional models such as ARIMA, profit, and deep learning models like TCN just last year. And we try these along with our classical models on the data set to provide better performance. Now, if you remember earlier, I did mention one of our goals is to scale AI. And we are able to do that now with our many models approach. And what this does is instead of having one model to forecast for your entire store, let's just say if you're doing a prediction on orange juice sales, you might have multiple stores across the globe. We are introducing this grouping feature, which is the first step towards hierarchical time series. So this will allow for a more detailed forecast. And later on in this presentation, I would demo how you can scale and build multiple models in parallel. The next thing that is important is interoperability. So now after training, we often get questions such as, what did you do? Like, how did you get those models? How are these predictions made? So to answer the first question on what did you do, we want to make sure the entire process is transparent. Let it be, you want to know the hyperparameter values that were used, or what kind of featureization went down. We are able to provide all that information. So we show the transformers and parameters. Any values we altered in the data set, let it be imputing missing values or train valid splits, we are able to provide you with all that information with our featureization transparency. And I would show you some of the code on how you can do it. And I will share some docs and links that you could see if we don't get to cover everything today. So the next question is, how are predictions made? And this is where our interoperability story comes in. So right now we do have this visualization dashboard where you're able to see which features played an important role in the predictions. So for example, if you're trying to figure out if employees will leave a company or not, we can see that duration plays an important role on this prediction. Maybe NR employed. So all of these features have an important role in the predictions. And within this dashboard, we support global importance, summary importance, and local importance. And what I mean by local importance is it takes an individual point, data point, and we're able to see it across the different features, which of those features play an important role on that individual data point. So that's basically a top level, high level breakdown of some of the features that we currently support. So what I'm going to do now is introduce personas for us. So we have seen the demand for AI growing, and we are talking about democratization. But let's talk about what that actually looks like. So I'm going to just go ahead and tell you what this chart over here is. So on our y-axis, we go from no ML experience to machine learning expert. And on our x-axis, we have coding comfort and preference going from no code to code. And let me introduce our four personas. So on the top of the quadrant, we have our machine learning pros. They have been in the space for some time and are looking for ways to better their workflow. And in the bottom, we have the no ML experience. These guys are domain experts who really understand their business needs and know that ML can help them. So let's go ahead and dive into our first persona for today, and that's going to be Raj, who is a no code and no ML. So to tell you a little bit about Raj, he is fluent in business intelligence and the data that empowers it. He understands what ML can do for him, but Raj does not have the time to experiment with creating models and tuning production models. Raj wants to get started quickly. So let's see how we can help him do that using the AutoML UI. And for this example, I'm going to go ahead and use the bank marketing data set. So this data is related to the direct marketing campaigns of a Portuguese bank institution. And the whole idea here is we're going to predict if a client will get a term deposit or not. So yes or no. So this is a classification example. So I'm going to go ahead and switch over to my demo screen. So right now we are looking at the Azure Machine Learning Studio. So I'm going to just quickly dive into some of the areas that you could use and then dive into the AutoML UI demo. So this is the home page. Right here, if you can see, this is the authoring tab. Under authoring, you will see things where you can build, train, evaluate, and deploy machine learning models using any of these authoring tools. Today, we'll be using notebooks and automated ML, but I definitely recommend that you try out Designer on your own time. One important thing is before you use our machine learning studio, you will need to create a workspace. And you could do that by accessing portal.azure.com, search for machine learning workspace, go ahead and do that setup there. And then you could easily access it from here. You will need an Azure subscription. And there is a way to get the free subscriptions. I will paste the link for that on the chat after this presentation. So just so that you could get started as well. So that's authoring. Next is assets over here. And this allows you to prepare your data, run and monitor your jobs, view and deploy models, and manage real-time and pipeline endpoints. And again, today during our demos, we will dive in through some of these areas, just so I want to make sure you're a little familiar with it. And the final section here is management. Here you are able to view and manage the resources for your workspace. So now that you're familiar with our machine learning studio, I'm going to go ahead and dive into automated ML. And what you'll see here are some of the runs that I did a little earlier. For this demo, I'm going to go ahead and start a new automated ML run. So I'm going to go ahead and click on that. And the first thing that we need to do is select a data set. So we have a couple options here. As I mentioned earlier, you're able to bring your data set from local files, data store, web files, or open data sets. I'm going to go ahead and use this bank marketing data set that I created a little earlier and continue this demo. So I'm going to go ahead, click next, and the first thing that I will do is go ahead and view my data set. So if I click on this, what this does, it allows me to see what my data looks like. And if I go all the way to the end, I know this Y column is our prediction column, as we are identifying if they're going to get a term deposit or not. And then this data statistics tab over here provides some summary statistics. So it'll give me details on some of my features. For example, age is an integer value, has a min and max value of 17 and 94. And this is just to give me a better understanding of my data and feel comfortable with it before I go into the training experience. So now that I've looked at my data, I'm going to go ahead and configure my run. So I have a couple options here. I need to first start off by giving my experiment a name. And I could either use an existing name or create a new one. So for this example, I'm going to go ahead and use an existing name. I'm going to call it bank marketing. And what this does is when I use an existing name, all my experiments for this bank marketing data sets is going to be grouped into this bank marketing experiment folder. Now, if I want to make sure this experiment is in a new folder, I could go ahead and create a new name. Once I do that, I could go ahead and choose my target column, and we know that is Y over here. And then I'm going to choose my compute cluster. In this case, I could just go ahead and choose the CPU one that I created earlier. And this will automatically scale to my experiment needs. The next step is to choose my task type. And we already know that this is a classification example. But again, AutoML does support regression and time series forecasting. Some things that you could do is a little advanced is view the additional configuration settings. And here you get to choose the type of primary metric you're optimizing on. So for example, the default was accuracy, but maybe I might want to do AUC weighted. You get to block some algorithms. For example, you might just want to run it on light GVM, so you could go ahead and block everything else. We also have some exit criteria that I said earlier. So like if you want your experiment to only run for 2 hours, you could go ahead and specify that over here. Or once it reaches a specific score for AUC weighted, it would go ahead and end the experiment. So these are just additional configurations to make so that you could tweak your experiment a bit better to get better results. I'm going to go ahead and leave it with the plain vanilla settings. And I'm also going to show you the view featureization settings here. So this is how you can customize your featureization through the UI. You got the option to include or exclude columns, set the feature type. So remember, age was set as numeric, but maybe we want it to appear as text. We could impute all these missing values with mean, most frequent, or median. So we have all those additional options over here. So I'm going to go ahead again, leave it the way it was, and then I'm going to go ahead and click finish. And what's happening here is AutoML is going to intelligently test the multiple models for me, and it will return the optimized one. So this run is going to launch, and we're on the main details page. Right now, you can see the status is non-started. I'm going to go ahead to experiments over here and open up a bank marketing experiment that I completed a little earlier. So here is a bank marketing experiment. And once this loads, you will notice that this is the run that I just launched. It's in the status of starting. I'm going to explore this one that I completed just a little earlier. So right now we see the status is completed, and under the best model summary, we could see the algorithm that was chosen. So in this case, it's voting ensemble. We could see the optimized metric was accuracy, and we see the score over here. But if we want to explore additional metrics, we could go ahead and do that from here. So for example, I could see that AUC macro has a score of 0.9742. And if that helps me better understand if this model is good enough or not. Additional things that we could do is we could see all the settings that we selected in our run. Just in case if we want to launch another run, we could go ahead and just look at these settings over here. If you remember, I was talking about data guardrails earlier, and you could view all of that from this tab over here. So in this case, we did some validation split handling, class balance detection, and it alerts you about all that information so that you have more information about your run. Now, AutoML is not only going to return that optimized model for you. So we saw that voting ensemble was the best model, but over here we could also see these additional models, like for example, sparse normalizer and all these additional models that were explored in this individual run. I'm going to go back to the details page and open up voting ensemble, for example. This is the model that was recommended. If I click on the explanations tab over here, this is how I could see the interpretability dashboard. So I could see that duration played an important role in the term deposit criteria for whether a person will get a term deposit or not. And then I could also explore summary importance or local importance. Once this dashboard does open up, I could go ahead and click on one of these. And this will open up the local importance value. So I can see for that individual local feature, you can see that duration and NR employed had a negative impact on whether a person will get a term deposit or not. So just other additional information for you to know when you're exploring your run. And then we have metrics. So this will allow you to see additional visualizations to better understand your model and see if it's good enough. So for example, I have the gain curve, lift curve, and again, you could easily take this and communicate this with your data scientist team to prove that this is how the model performed. Now, once you're happy with your model, you could go ahead and deploy it with a one-click deployment. So all you need to do is give your deployment a name. In this case, I'm going to call it bank marketing. And then I need to decide where I want to deploy it. Azure Container Instance, which is a testing environment, or Azure Kubernetes Service, which is a production environment. So I'm going to go ahead and click ACI, click deploy, and then what's happening is it's automatically going to register my model, and I could see it all from here. So this is where the registered model will appear. I can see this bank marketing right here, and if I go to endpoints, I can see the deployed model. So that's how the UI works. So the next thing that we're going to go look at, so I'm going to switch back to the slides. So just to dive back into Raj, with the AutoML UI, we were able to easily start an experiment, and he was able to quickly train a model. He got the results, all those metrics and visualizations that could easily communicate with his data science team. And the explainability dashboard allowed him to better understand what's happening behind the scenes. So the next demo, we're going to look at someone like John. And John has a basic understanding of how ML works. He does not have the time to experiment with creating and tuning production models. And he, again, wants to start quickly. The highlight about John is that he does have coding experience. So I'm going to go ahead and dive into John. So let's go ahead back to this screen. And this time we're going to take advantage of notebooks. But before we go to notebooks, one important thing is you'll need to create a compute instance, which allows you to launch the notebook. So in this case, I have this June 2021 running, and you have the option to run it on Jupyter Lab, Jupyter, RStudio. I'm going to go over to the notebooks tab just to show you how this looks like. And you can see how these different folders where I have all my different notebooks. I'm going to go ahead and launch this using Jupyter Lab. So we're going to be here. And in this example, we're going to go ahead and use a forecasting energy demand notebook. And just a heads up, we do have a bunch of sample notebooks that you can access if you are interested. And so let's go ahead and start this experiment. So here, the first thing that you'll need to do when you're using our notebooks is do all the original setup. So bring in all the required libraries is what we're doing over here. And then you'll need to call in your workspace configuration. So this is where you get the chance to name your experiment, similar to how we did in the UI. And then this will load up all the information about your workspace. The next thing we'll need to do is go ahead and create or attach AML compute similar to how we did in the UI, and that's what we're doing over here, calling it energy cluster, and then bring in our data. So this is a forecasting example as we are predicting the energy demand forecast, right? So in this case, we'll need to specify the target column as well as the time column. So in this case, demand is the target column and timestamp is the time column name. And we could see how this data actually looks like right here. We're going to go ahead and split the data and do all those things that we want to do with our data right at the top. And then I'm just going to quickly scroll down so then I can show you the AutoML configuration. So similar to how we did in the UI, this is how you specify the task type. In this case, it's forecasting. You could choose your primary metric. You could go ahead and block some algorithms. And then all these additional parameters you could find here, and like you could tweak it up based on whatever you're trying to do for your experiment. And then you could go ahead and launch your remote run. And what's great about using the notebook is it's integrated with the machine learning studio. So you could access the run and all those information right from the same view you had when you're using the UI. So I'm not going to go and explore everything again, but here you could see that voting ensemble is the recommended model. If you want, you could go to the additional models tab and you can see all the additional models that were explored during this run. So this is just how you can do end-to-end experience on the notebook. So similar to the UI, but all with code. So switching back to the screen. So we see with John, we were able to create an experiment pretty quickly using code. This is what he's familiar with. He knows his data very well, and he was able to easily communicate all of that again with his team with using an environment that he is familiar with. Now, for the final demo for today, I know we only got 10 minutes left. I'm going to go ahead and talk about someone who's a little more of an ML expert and who loves to code. We're going to look at Danielle. And Danielle, she's very familiar with Python. She often tunes algorithms and creates machine learning models using notebooks. And her goal is that she wants to be able to build models at scale. So let's see how we can do this with Danielle. So for this example, we're going to use the Orange Juice Sales Many Models notebook. And this notebook is located in our solution accelerator. So you could access this by accessing github.com, Microsoft Solution Accelerator -many models. Again, I'll paste all the links at the end of this presentation. And how the solution accelerator works is if you're trying to build multiple models, for example, in this orange juice sales example, you might want to build multiple models for every store and brand. If you have a specific way to group it, this solution accelerator will be perfect for you. I'm going to go ahead and open this up in, again, the notebook experience. So if you can see over here, if I click on many models, it should open up the solution accelerator. I just cloned the GitHub repo, and you have a couple options. You could either use automated ML or custom script, where you bring in your own training script to train the multiple models. I'm going to go ahead and use automated ML in this case. And the first step is to prepare your data. So I'm going to open up this data preparation notebook. And again, in this case, we are training or models to predict orange juice sales. And I will show you how you can do this with 10 models. And when you're preparing your data, what's important with the solution accelerator is you need to bring in the data equivalent to the number of models you're trying to build. So let's just say you're trying to build 10 models, then you'll need to bring in 10 files, and you're splitting these files up based on the group columns, in this case, store and brand. Again, the process is very similar to the energy demand forecasting notebook. You connect to the workspace, and then in this case, we have our data stored in a blob store. So we're just connecting to the data store over here and creating our file data sets. We're splitting it up for both training and also inferencing, and that's what we're doing here. And then once we have our data registered, we could go ahead and switch over to the training notebook. And in the training notebook, again, we're calling in our workspace, data store, and experiment, setting up all the required packages right here in start. And then we're going to call the registered file data set that we set up in the previous notebook. And when you're using this notebook, you'll notice it says OJ data small versus OJ data. So we have the option to either train 10 models or 10,000 models in this one notebook. I'm going to show you the 10 models. And then we could go ahead and build our training pipeline. So again, you'll need a compute, and that's what we're doing here. We're setting it up. And you'll notice that the workflow is very similar to just running a single model, but this time we're taking advantage of something called parallel run step, which will help us parallelize the training process. So once we have our compute set up, we're going to go ahead and set up our AutoML configuration, and that's what we're doing over here, specifying our task type, in this case forecasting, choosing our primary metric, specifying how many iterations, in other words, how many models per AutoML run we want to train, in this case 15. Two of the important columns here is group columns and grain columns. So group columns is the number of models we want. So in this case, it's split by store and brand. And grain columns identifies a unique time series in your data. So again, often the group and grain will be the same. In this case, it's store and brand again. And then we could go ahead and set up our parallel run configuration. A couple things that we need to tweak here are our node count and process count per node. And this basically helps you improve the concurrency and how fast these models will be trained. And then we could go ahead and launch this run. And I'm just going to show you what this looks like from the Azure portal quickly and what a many models run looks like versus when it's just a single run. So with this many models run, you'll see this training pipeline. And if you click on child runs, if you remember with the single AutoML run, you would only see one AutoML run, but here we have 10, which specifies the 10 models. So we're training 10 models using AutoML, and under each AutoML run, you'll see multiple models in that case. So if I click on this one over here, this is one of the models trained. And if I go under the models tab, you'll see all these child runs, which recommends some of the best models. So that's just the training process. The final step is forecasting. I'm just going to skip through quickly. The process is very similar to the training notebook. So you're calling the registered file data set, building your forecasting pipeline. I'm just going to show you what the output looks like just so that you get an idea of what this notebook does. So we're using batch inferencing over here, and this is what the predictions look like. So in the end, we get one output of our actual, which in this case is quantity, versus the predicted. And you could use this to compare your results. So this is basically how you scale and build multiple models using our many model solution accelerator. So I'm going to go dive back to the slide. So today within this presentation, you learned about the different tools that AutoML has, let it be feature engineering, let it be time series forecasting, let it be model interpretability. Now you might wonder how you can get started with your tool or your scenario. So these are all the links that I had for you today. You can definitely go ahead and try it for free. Visit ml.azure.com. You will need your subscription, and then you could go ahead and get started. So thank you.
Great, thanks, Aniththa. We have quite a lot of questions, actually. Can you open up the Q&A tab to see if you can see the Q&A? We can go through that. We have a few, yeah, we have a few minutes.
Okay, great. Yeah, let's start off with the first question. Does it support image data and object detection? So right now, AutoML does not support image data, but if you are looking to support image, we do have the whole data labeling tool that you could use. I could paste some links after this presentation that you could access. I'll actually share it, and you guys could take a look at that. So next question. How can you impute missing data with the mean, median, and mode? So right now we do only support mean, median, and mode from the UI. There are some additional configurations that you could explore when using the SDK. Again, I'll share the documentations on how you can access all of that. And also we do have notebooks, sample notebooks that will help you get started and see what the different things that you could do with featureization is it possible to compare different algorithms with the same data? So this is a really good question. So with AutoML, what's happening is it's using different algorithms with the same data. So you could either like block those algorithms or specify which algorithms you want to try. So remember, AutoML already has a set of algorithms. You have to choose one of those algorithms on which ones you want to use, but it's going to go ahead and train the models with that algorithm. So it is going to use the same data, and you'll see multiple models in the end. So there's a question about, is it possible to select hyperparameters in deep learning model? So we do have this additional tool called Hyperdrive outside of this AutoML tool that you can use if you're looking to just tune your hyperparameter values. Again, this is AutoML has its own hyperparameter tuning going on, but if you're only looking to tuning your hyperparameter values, you could use Hyperdrive. And it's part of the Azure Machine Learning offering. Do you have any suggestions for AutoML platform? Is Azure the best one? I can't really speak for other platforms, but what's good about using Azure is you get access to all these other tools, like all of the Azure services. And within Azure Machine Learning, let it be bringing in your data set to deploying your models, you're able to do all of that in one spot, which is why I love Azure Machine Learning. I think we're at time. I could continue to type the answers for these and we could continue. That's good. Let me know.
We can go go through a couple of more.
Okay, cool. Yeah, I could go through a couple more. How do you monitor models in production for concept drift? If there's a drift, do you support automatic retraining? This is actually a great question. So we do have an offering called Data Drift. So today I did only dive into automated ML, but Azure Machine Learning has a lot of offerings. Let it be the whole ML ops piece where you're able to bring your models to production, where you're able to retrain. There's the whole Data Drift offering. So like today we just did a deep dive into automated ML. I'm gonna make sure you guys have access to our docs and our sample notebooks so you can see all the other offerings within Azure Machine Learning. Remember, AutoML is just one of those offerings. Let's see if there's anything I need to answer. Do you support computer vision classification models? We currently do not support that with automated ML. Next question, how much does AutoML cost? Do you charge per prediction or per training? So the cost is for the compute. We do have a documentation on the different sides of compute and the price for that. Again, I'll make sure to share the docs for everything. That way you have access to all that information. Let's see. Does Azure ML have deep learning capability? It does. And with AutoML as well, we do use some deep learning algorithms. And if you're looking to use it outside of AutoML, you could definitely do that. And we do have some sample notebooks on how you can do that. So I'll definitely share that. Are we good to go?